Hi friends, welcome to my channel. Today we are going to see about an logic gates which is widely used in many electronic devices for taking an logical based decisions. Okay guys, now let me get into the video. A logic gate is an electronic device that provides logical decisions based on the various combination of digital signals accessible on its inputs. A digital logic gate can have more than one input signal but has only one digital output signal. Guys, a logic gate is nothing but it is an electronic device. It will provide some logical decisions based upon the input that we provided to it. In digital logic gate, it can have more than one input signal, but it will have only one output signal, that is on or off. Thus, in logic gates, there is an seven basic gates, that is AND, OR, NOT, NAND, NOR, XOR, and XNOR. These are the seven logic gates that we are going to see today in this video. Okay, guys, now let us see one by one. First one is an AND gate, and this is the symbol of AND gate. Yes, in AND logic, if all inputs are on, the output will be on. That is, guys, in the AND logic, if the all inputs that we are provided to the gate is in on, the output will be in on. Yes, now let us see its truth table for an easy understanding. This is the truth table. Consider we having an A and B as input and output. If the two inputs are in 0 0, the output will be 0. Or if the two inputs are 0 and 1, the output will be 0. Or if the two inputs are 1 and 0, the output will be 0. Or if the two inputs are 1 and 1, the output will be 1. Guys, by observing that, you have understood that if the all the inputs are 1, the output will be 1. 1 is nothing but off and 0 is nothing but an off. Sorry, 1 is nothing but an on and 0 is nothing but an off. That is, in AND gate, if the all inputs are on, then only the output will be on. Otherwise, the output will be off. Okay guys, now let me see about an OR gate. And this is a symbol of OR gate. Guys, in OR logic, if one input is on, the output will be on. Guys, this is nothing but if in OR logic, if the all inputs are 0, the output will be 0. Okay, now let me see its truth table for an easy understanding. Consider we having an A and B as input and it will have an output. If the inputs are 0 and 0, the output will be 0. Or if the inputs are 0 and 1, the output will be 1. Or if the inputs are 1 and 0, the output will be 1. Or if the inputs are 1 and 1, the output will be 1. Yes, by observing this truth table, hope you understand that if the any of the input is in on in OR gate, the output will be on. Okay guys, now let me see about an NOT gate. And this is a symbol of NOT gate. As in NOT logic, if the input is in on, the output will be off and vice versa. As in not logic, it is nothing but if the input is in on, the output will be off, which is opposite. Now let us see its truth table for an easy understanding. Consider we having A as input and its output. If the input given to the nodal object is off condition mean it will provide on, or if the input given to NOT gate is in on, it will provide off. So by observing that, hope you understand that if we provide, if the input is on, the output will be off, or if the input is off, the output will be on. Now let us see about a NAND gate. And this is a circuit diagram of NAND gate. In NAND logic, if one input is off, the output will be on. Now let us see its truth table for an easy understanding. Consider we having A and B as input and output. If the inputs are 0 and 0, the output will be 1. Or if the inputs are 0 and 1, the output will be 1. Or if the inputs are 1 and 0, the output will be 1. Or if the inputs are 1 and 1, the output will be 0. Hope you guys by observing this truth table you came to know that if the all the inputs in NAND gates are on, the output will be 0, that is off. Otherwise the output will be 1, that is nothing but on. So for getting an off condition in NAND gate, our all the inputs should be in on. Now let us see about NOR gate. This is a symbol of NOR gate. In OR logic, if all the inputs are off, the output will be on. Now let us see its truth table for an easy understanding. Consider we having two inputs and outputs. If the two inputs are 0 and 0, the output will be 1. Or if the two inputs are 0 and 1, the output will be 0. Or if the two inputs are 1 and 0, the output will be 0. Or if the two inputs are 1 and 1, the output will be 0. Hope you guys by observing this truth table you understood that if the all inputs in NOR gate is in off condition, it will provide on, which is nothing but 1. So for getting an output signal as on, our all the inputs should be in off condition in NOR gates. Now let us see about an XNOR gate. And this is a symbol of XOR gate. As in an XOR gate, if the all inputs are dissimilar, the output will be on. Now let us see its truth table for an easy understanding. Consider we having an A and B as input and output. If the two inputs are 0 and 0, the output will be 0. Or if the two inputs are 0 and 1, the output will be 1. Or if the two inputs are 1 and 0, the output will be 1. And if the two inputs are 1 and 1, the output will be 0. Hope you guys by observing this you understood that if the two inputs are in opposite, which is nothing but 1 and 0 or 0 and 1, we will get the output as an on, otherwise we will get as off. Now let us see about XNOR gate. And this is a symbol of XNOR gate. As in XNOR logic, if all inputs are similar, the output will be on. Now let us see its truth table for an easy understanding. Consider we having an two inputs A and B and output. If the two inputs are 0 and 0, the output will be 1. Or if the two inputs are 0 and 1, the output will be 0. Or if the two inputs are 1 and 0, the output will be 0. And if the two inputs are 1 and 1, the output will be 1. Hope you guys by observing this you got that if the all the inputs are in similar, we will get an on output, or otherwise we will get off as an output. Okay guys, now let us see one small application by using an logic gate, that which is nothing but OR gate. Consider we having a two switches and one lamp, and we having an OR logic gate, and using a connection we connecting and switches and lamp, which is nothing but an two-way switch. Consider initially the two switches are in off condition. You guys know in OR logic, if any of the one input is on, the output will be on. Or if all the inputs are in off, the output will be off. Now here the two inputs are in off condition. So by the truth table, if the two inputs are off, the output will be off. Now let us go to the another condition. See here, if here now the two inputs are in on condition. You, we guys know in our logic, if any of the one input is on, the output will be on. So now the lamp is glowing. Now let us go to the next condition, that is off and on. See, in this condition, one input is in 0 and another input is in 1, that is off and on. So now the lamp is glowing. In this condition, one input is on and another input is off. So by our logic condition, if any of the one input is on, the output will be on. Hope the logic is satisfied. Okay guys, that's all about this video. Now then we will see in next video. Thank you.